According to the 1999 National Electrical Code, ceiling fans are classified as fixed appliances. When wiring ceiling fans, it is important to consider whether to use a general-purpose circuit or a dedicated circuit. Ceiling fans can be wired to a general-purpose circuit if the total load of the circuit does not exceed 80% of the circuit's capacity. If the total load of the circuit, including the ceiling fan, exceeds 80% of the circuit's capacity, then a dedicated circuit is required for the fan. To determine the total load, you must add the wattage of all appliances and devices connected to the circuit. Here is an example. Consider a 15 amp circuit with a ceiling fan rated at 100 watts and other devices totaling 900 watts. The total load is calculated as 100 watts for the fan plus 900 watts for the other devices, which equals 1000 watts. To find the percentage of the circuit capacity being used, divide the total load of 1000 watts by the total capacity of the 15 amp circuit, which is 1800 watts, calculated as 15 amps multiplied by 120 volts. This yields approximately 56%. Since the total load is less than 80% of the circuit's capacity, the ceiling fan can be wired to the general-purpose circuit. Note that the 80% rule applies to the ampacity, which is the current carrying capacity of the circuit, not the wattage directly. This distinction is important to understand for safe and compliant wiring practices. It's also important to check local electrical codes and regulations because they may have additional or different requirements than the NEC. For example, some jurisdictions might require arc fault circuit interrupters or size for ceiling fan circuits, even if the NEC does not specifically mandate it in all cases. When calculating the total load on a circuit, remember to account for the volt amp or voltamps, rather than just watts for devices like lighting fixtures with ballast or electronic components. The volt amp value provides a more accurate representation of the current draw. For instance, if you have a fluorescent light fixture with a ballast, its volt amps rating might be higher than its wattage rating. Use the volt amps value in your load calculations to ensure that you are not overloading the circuit. It's also essential to consider the wire gauge when wiring a ceiling fan. The wire gauge must be appropriate for the circuit's amperage rating. For a 15 amp circuit, 14 gauge wire is typically sufficient, but for a 20 amp circuit, 12 gauge wire is required. Using the wrong wire gauge can lead to overheating and potentially create a fire hazard. Check the National Electrical Code tables, such as Table 310.15 V16, to determine the appropriate wire gauge for the circuit's ampacity and conductor type. Additionally, ensure that all wiring connections are secure and properly insulated. Loose connections can cause arcing and overheating, posing a significant safety risk. Use wire connectors that are appropriate for the wire size and type and make sure they are tightened properly. Wrap all connections with electrical tape to provide an additional layer of insulation. Grounding is another critical aspect of wiring a ceiling fan. The fan must be properly grounded to prevent electrical shock. Connect the fan's grounding wire, usually a green or bare copper wire, to the grounding terminal in the electrical box. Ensure that the electrical box itself is also properly grounded. If the electrical box is metal, it should be grounded back to the panel. If the box is non-metallic, ensure that there is a grounding wire available to connect to the fan. If you are replacing an old ceiling fan, inspect the existing wiring for any signs of damage or deterioration. Look for cracked or frayed insulation, loose connections, or corrosion. If you find any problems, replace the damaged wiring before installing the new fan. It's also a good idea to test the circuit with a multimeter to ensure that it is properly wired and that there are no shorts or open circuits. When installing the ceiling fan, follow the manufacturer's instructions carefully. The instructions will provide specific details on how to mount the fan, wire it, and connect the various components. Make sure that the fan is securely mounted to the ceiling joist or suitable mounting bracket. A wobbly or unstable fan can be a safety hazard. If the ceiling fan includes a light kit, be sure to wire it correctly according to the manufacturer's instructions. The light kit may have its own separate wiring connections and switches. Also, consider the type of light bulbs used in the light kit. Use bulbs that are compatible with the fixture and that do not exceed the maximum wattage rating specified by the manufacturer. Furthermore, think about the location of the ceiling fan in relation to other objects in the room. Ensure that the fan blades have sufficient clearance from the ceiling, walls, and furniture. Insufficient clearance can cause the fan to operate inefficiently or create a safety hazard. Consult the manufacturer's instructions for recommended clearance distances. When working with electricity, always take precautions to protect yourself from electrical shock. Turn off the power to the circuit at the circuit breaker before doing any wiring. Use insulated tools and wear rubber-soled shoes. Never work on electrical wiring when you are wet or standing in water. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the ceiling fan. An electrician has the knowledge and experience to do the job safely and correctly. Additionally, after installing the ceiling fan, test it thoroughly to ensure that it is working properly. Check that the fan blades are rotating smoothly and that there are no unusual noises or vibrations. Verify that the light kit is functioning correctly and that the fan speed control is working properly. If you encounter any problems, troubleshoot the wiring and connections until you identify and resolve the issue. Keep in mind that the National Electrical Code is updated periodically, so it is important to stay current with the latest requirements. Consult the most recent version of the NEC and any applicable local codes before doing any electrical work. By following these guidelines and taking the necessary precautions, you can safely and effectively wire a ceiling fan in accordance with the National Electrical Code. Remember to prioritize safety and consult with a qualified electrician if you have any doubts or concerns. When determining whether a ceiling fan can be wired to a general-purpose circuit or requires a dedicated circuit, it's also important to consider any future additions to the circuit. If you anticipate adding more lights, appliances, or devices to the circuit in the future, it may be wise to install a dedicated circuit for the ceiling fan, even if the current load is below 80% of the circuit's capacity. This will ensure that the circuit has sufficient capacity to handle the additional load without becoming overloaded. Furthermore, consider the type of ceiling fan you are installing. Some ceiling fans have high wattage motors or include additional features such as remote controls or energy-efficient motors that may increase their power consumption. Check the fan's specifications to determine its wattage rating and use that value in your load calculations. It's also worth noting that some jurisdictions may have specific requirements for the type of circuit breaker used for ceiling fan circuits. For example, some jurisdictions may require the use of arc fault circuit interrupters, or a size for all branch circuits that supply ceiling fans. A size are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. If an arc fault is detected, the FSI will trip the circuit breaker, interrupting the flow of electricity and preventing a fire. Check your local electrical codes to determine if FSIs are required for ceiling fan circuits in your area. In addition to the 80% rule, it's also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. To minimize voltage drop, use the appropriate wire gauge for the circuit and keep the circuit length as short as possible. The National Electrical Code provides guidelines for calculating voltage drop in branch circuits. When wiring a ceiling fan with a light kit, it's important to ensure that the light kit is compatible with the fan's wiring and control system. Some ceiling fans have integrated light kits that are wired directly to the fan's motor. Other ceiling fans have separate light kits that are wired independently. If you are installing a separate light kit, make sure that it is compatible with the fan's wiring and that you follow the manufacturer's instructions carefully. Also, consider the type of light bulbs used in the light kit. Use bulbs that are compatible with the fixture and that do not exceed the maximum wattage rating specified by the manufacturer. LED bulbs are a good choice for ceiling fan light kits because they are energy efficient, long-lasting, and produce very little heat. When working with electrical wiring, always use proper safety equipment including insulated tools, rubber gloves, and safety glasses. Never work on electrical wiring when you are wet or standing in water. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the job. An electrician has the knowledge and experience to safely and effectively wire a ceiling fan in accordance with all applicable codes and regulations. Finally, after installing the ceiling fan, test it thoroughly to ensure that it is working properly. Check that the fan blades are rotating smoothly and that there are no unusual noises or vibrations. Verify that the light kit is functioning correctly and that the fan speed control is working properly. If you encounter any problems, troubleshoot the wiring and connections until you identify and resolve the issue. It's also a good idea to periodically inspect the ceiling fan for any signs of wear or damage. Check the blades for cracks or bends, the motor for overheating, and the wiring for loose connections. If you find any problems, repair or replace the fan as needed. By following these guidelines and taking the necessary precautions, you can safely and effectively wire a ceiling fan in accordance with the National Electrical Code. Remember to prioritize safety and consult with a qualified electrician if you have any questions or concerns. In summary, firstly, determine if the ceiling fan is considered a fixed appliance according to the NEC. Secondly, assess whether the total load in the general purpose circuit, including the fan, stays below 80% of its capacity. Thirdly, calculate the total load by adding the wattage of all devices on the circuit. Fourthly, if the load exceeds 80%, install a dedicated circuit for the fan. Fifthly, use the correct wire gauge for the circuit's amperage, consulting NEC Table 310.15. (16). Sixthly, ensure all wiring connections are secure and properly insulated. Seventhly, properly ground the fan to prevent electrical shock. Eighthly, follow the manufacturer's instructions for installation and wiring. Ninthly, test the fan thoroughly after installation to ensure proper function. Tenthly, periodically inspect the fan for wear and damage, addressing any issues promptly.